Welcome to the Footbridge Conference YouTube channel. Today's presentation will be by Jürg Conzett of Conzett, Branzini and Partner, a Swiss firm renowned for its bridge designs. And today's project will be, well, actually, let me have Jürg tell you exactly which project it is.
Hello, I'd like to present a project for a small trail in the southeast of Switzerland. It's called Ponte Cavagliasc. It's situated south of Bernina Pass in the Poschiavo Valley. Looking at the map, you see the famous Bernina railway descending from 2,200 meters on the Lago Bianco on the top of the map via Alpgrün, famous viewpoint, down to the plain of Cavaglia and then further down to Poschiavo, more than 1,000-meter level difference. And halfway of this descent in this plain of Cavaglia, there are very peculiar rock formations built by the glaciers with holes in the rock by drilling stones. And this is already actually a place called Giardino dei Ghiacciai, the glacier's garden. And this organization wanted to extend their trail network through a gorge. And this is a very special gorge. I will show you. Okay, on the left side, you see part of the railway crossing the gorge of the Cavagliasc River by a small stone bridge. And then you see the level lines of this gorge is very confusing because in many sections, the gorge enlarges to the bottom. It's really a very peculiar, almost underground world where we enter, and it was only possible to get a view into this topography by creating a physical model and then later on working on a 3D computer model. So here the new trail is sketched in green. It starts on the left side of the railway bridge. It goes down some steps, crosses under the railway bridge, re-enters a little bit, and then goes along like the edge of the really deep vertical rock faces. And after about 70 meters, it crosses a very spectacular rock face with 2 stone arches, and then finishes with some other steps leading to a work road for the local power station. One aspect which was important is that the region is characterized by good stones. We have stone quarries, and it was one of the aims of this project to use the local stone as much as possible, to create something a bit like an exhibition of the possibilities of the local stone. So this is one of the applications of the local stone. The bridge crossing under the railway arch bridge, you see above, having the deep gorge underneath, supported by a transversal arch and flanked by 2 steps. It's not a big bridge. It has spans of 6-7 meters. And so the idea was to use blocks of local granite and post-tension it with steel bars. This is an old idea created by Heinz Hossdorf in the 1950s. And I think it's an interesting application for today's working with stone. So finally, we could build this bridge. It's almost ready now. So here you see a drawing of this bridge, 2 stairs on both sides, post-tensioned by these straight high-tension steel rods with nodes in concrete. These are the green parts as supports and as intermediary nodes, so that all the post-tensioning can be effected with straight bars. In the middle, under the section of the railway bridge, you see the transversal girder. This is the stone bridge in the stage of construction. Post-tensioning is always already applied. You still see the scaffolding underneath the bridge. So in fact, finally, it will be much more spectacular. And you see the transversal arch consisting of 3 stone blocks. It against the railway bridge above with vertical hydraulic jacks to test if there are really no hidden clefts in the granite, and we put it till the design level of force, which I think never again will be reached, to guarantee that the stone is safe.
Wow, I mean, this is already amazing. I just can only imagine what it would look like when the scaffolding is gone.
Yes.
What's the slenderness?
Yeah, it's 20 centimeters thick and a span of 534 meters. This is about 1/18th, maybe, like that. Not very slender, but to come back, I can say one thing was, first, I put some roller bearings at the ends to make sure that post-tensioning stays within the structure. It has no kind of, parasite stresses due to temperature differences and so on. And then during winter, we realized that there is much water, much ice. And if you look at the drawing, that joints between the bridge and the abutments would have been very bad, because there the ice enters and it would push the whole thing into pieces. So it was clear after this winter experience that we have to create the whole bridge monolithically, to link it monolithically with the abutments and the rocks on both sides. And therefore, this aspect of temperature change, we are on a level of 1,600 meters, so the differences between summer and winter are quite remarkable. These aspects become very, very dominant. You could imagine that when it's very cold, that the whole bridge lifts from the central supports or things like that. But then I found in the literature about a stone dam built in the 1920s in Switzerland near the Gotthard Pass by Hans Studer, an eminent engineer who built many stone viaducts for the Russian railways. And he mentioned that the granite stone has less expansion coefficients for temperature changes and has a low modulus of elasticity, and therefore he thought to build an arch dam in stone would be a very good technique. And finally we made some measures concerning elasticity, and it's true. It's a soft material compared to concrete, which for me was astonishing. But finally we realized that these aspects of temperature change and parasite stresses are not that critical as we feared at the beginning. So this was an interesting experience, to build with stone, to build with masonry, stone and joints of a liquid mortar. And still, I think this somehow traditional way of building with natural stones has its secrets, which are to investigate. So this is another sketch of this Lehnenbrücke, which is made in a very traditional manner with masonry. In the background, you see the railway viaduct and the other stone bridge. So everything is very close. It's just about 80 meters of walking this path. And also here we found a really good local entrepreneur who was capable to build that without a lot of discussions. So this shows one of these arches still under construction with local stone, just collected from the ground. For the walls, the stones of the arch are cut, and the stones for the steps are cut and treated. So again, different aspects of this local stone can be seen in this very, very small bridge. Yeah, now they are finishing the works with railings, and it's planned to open this trail in July of this year.
Very nice. So everyone can just go on it once it's finished.
Yes, it's like a public path. It's closed in winter.
Mm-hmm. Well, you probably slip on it.
Lots of snow, and it's just an open entry. You can go further to even bigger rock holes formed by the glacier. There is a little information point. There is a little restaurant. You're free to pay a contribution. And the interesting thing is the whole site is in a apparently small built landscape. You have the railway line, you have no road, the road goes at a different place. You have buildings from the power station dating back to the beginning of the 20th century, which are built in a very beautiful way, also with many local effects. This was National Romanticism, built by the famous architect Nicholas Hartmann. And so the whole context of this project is also worth to be visited. It's a great landscape. There are interesting interventions which are man-made, and so we try to continue this tradition.
Very nice. Well, I'm definitely blown away by what I've seen already, and I hope to be able to see it in the summer. Mm-hmm. And I encourage everyone to do the same. And thank you very much, Jürg, for your presentation. And
you're very welcome.
Yes, I hope to see you in person, either at the bridges that you just shown us or at the Footbridge conference.
Okay, thank you.